All right, so we've combined our like terms. Now let's move on to the second part of our lesson, where we are going to use algebraic tiles again, but now we're going to talk about distributive property. You know, I have my notebook from the very beginning of the school year, and when I turned to the third assignment from the beginning of the year, it was about distributive property. So we're just going back to what we've already done, and we're adding on to it. These notes are good to review. If you're forgetting what distributive property is, pause. Go look at these notes because you should have them in your notebook. All right, so let's use distributive property with algebraic tiles. Page M340, it has an example, and it's a great example for you to see what this is going to be about. But I also want to look at the very side of the page where it's got how to speak when you talk about these expressions. So on the very side, look, and it says, when you are speaking about an algebraic expression that is grouped together with parentheses, use the words the quantity. For example, they have the expression 2 parentheses x plus 3 parentheses, right? That we're used to saying open parentheses x plus 3 close parentheses. But what you're supposed to be saying is 2 times the quantity x plus 3. So that's 2 times, because that's 2 outside the parentheses, the quantity, whatever's in the parentheses, x plus 3. All right? So they have an example on the page. You can look it over. It's 5 times the quantity x plus 1. And you'll notice that there are 5. The row has an x box and a 1 box. The girl on the side is saying this model's just adding the quantity x plus 1 5 times. Okay, cool. But I'm still a little bit stuck on distributive. So what we're going to do is we're going to skip around a bit. Let's go down 2 pages to M342. And there's a boy on the side. So I distribute like this. Look at his example. Okay? He took that 2 on the outside of the parentheses. He multiplied it times each of the terms on the inside of the parentheses. So instead of doing 2 times the answer, he did 2 times x and 2 times 2. He combined his like terms, he simplified, he got 2x plus 4. So that's what we're going to practice, is that distributive property right now. This is something you might want to add next to the boy. Oops, sorry, you should see one at a time. These are the steps to help you remember what to do. So you should distribute first. You should combine like terms. You should move the variable because you want it all by itself. You should add and then subtract together, remember, left to right. And then you multiply and divide, again, together, left to right. I have a fun little way to remember this. Don't call me after midnight. Distribute, combine like terms, move variable, add, subtract, left to right, and multiply, divide, left to right. So we're going to be following these steps. Write them down. All right, we have 3a. 2 times the quantity of x plus 4. So x plus 4 is what the tiles are going to be, and 2 is how many groups of tiles. So draw yourself an x tile, it can be any size, and draw yourself 4 1 tiles. Do you have it? All right, so you have x plus 4 more 1s, right? And then I have a second group of x plus 4 1s. So this would be my algebraic tiles for the expression 2 times the quantity x plus 4. Now let's solve it using those steps. Don't call me after midnight. To show my work, we should use these rainbows. So I have 2 with a rainbow to x, 2 with a rainbow to 4. That just helps me remember I've got to distribute to every single term. If you forget the 4, you're going to get it wrong. So 2 times x, well, I can't do anything there. I can't combine the 2 and the x because I don't know what the x is. So I just make it 2x plus, what's 2 times 4? 8. Got it? Let's try another one. We're going to go for B, okay? Miss A, fractions. I know. But instead of thinking that, let's go fractions. Okay. Because you can do it. And the sooner you start thinking you can do it, the better. So we have 2/3 times the quantity, 6x plus 12. Do your rainbow. Try the steps on your own. You've seen an example worked out. Do you have an example? Have you tried it? Are you stuck on the fractions? I hope not. Let's see. We have 2 times each of the terms inside. Now, I know that when I multiply fractions and whole numbers, I'm going to make that whole number over 1. Ooh, if you're stuck, write this down. Keep going. You have 2/3 times 6 over 1. You end up with 12/3 because you multiplied across. Simplify that. Well, 3 goes into 12 4 times, so my answer is 4x. Do the same thing with 12. Try it on your own. Don't wait for me. Hit pause and try it. Do you have an answer? You should have done 2/3 times 12 over 1 is 24 over 3, and that simplifies to 8 wholes. Now there's no variable, so this is just 8. Put it together into one expression. Do you have your expression written? You should have 4x plus 8. All right, let's try one more example. C. You have 2 times the quantity x plus 5 plus 4 times the quantity x plus 7. Oh, there's so much work, Miss A. Yes, there is, and it doesn't go away. So instead of saying, oh, there's so much work, we are going to say, I can do this. Might be a good idea to write that down, because you all can do this. I know you can. And we've got to keep thinking that. All right. Distribute what's on the outside of the parentheses to each of the terms on the inside of the parentheses. Try it. Do you have an answer? Let's see if you matched. So I distributed my 2, I distributed my 4. 2 times x leaves me with 2x. Then 2 times 5 gives me 10, and then 4 times x is just 4x, and 4 times 7 is 28. Directions said that I need to combine like terms, so I look at that expression, I say, what can be combined? Well, I have 2x and 4x, those are the same, and I have 10 and I have 28, those are the same. Notice how I circled my 2x and my 4x, I put a box around my 10 and my 28. So, 2x plus 4x, 6x. And then I've got 10 plus 28, that gives me 38. You combine them, and you end up with 6x plus 38. Can you combine 6x and 38? I hope you're saying no, because there's an x there. They cannot be combined if they do not have the same variable. We have one more thing to talk about. Skip down to page 44. Okay, I know we're skipping a lot. Again, those are really good practice problems. You should be going back and doing them on your own time. But right now, I want to look at 44. So there's a great example worked out on page 44 where you have 4x plus 8 divided by 4. That fraction bar, it tends to really trip students up because they think, oh, fractions, or wow, that's a lot of steps. I'm not really sure what to do first. Take it one step at a time and really look at the numerator and deal with the denominator at the end. Okay, so look at the example problem worked out. Let's go to page 45. And you've got Zachary at the top. It's not numbered, it's before number 6. So he has this problem, and it's pretty complicated. And he's supposed to combine like terms and write it as simplified as possibly. He wrote 2 different methods. is fine. It works. Method 2 is really the one I want you to focus on, though. It's what I said. He looked at his numerator, and then when he was done and he simplified it as much as he could, then he dealt with his denominator. So look at his example, hit pause, take some time and actually look through it. Look at his steps. Make sure you understand what you're doing. And once you've understood his methods, I want you to go back to 44 and I want you to do number 5. When you are done, you're going to bring me your textbook and show it to me. If it all looks good, you're going to go on to the next direction in the agenda. Good luck.